All right, let's take a look inside. So this guy, let me actually pull up a ticket because I remember that this one has been damaged by lightning. AHJ. I've been waiting. It took over 2 weeks to get to me. Doesn't currently work. Had it in a basic computer. There was a flicker in the lights, and the next time it was turned on, both power supply and motherboard were dead. So this has been damaged by weather, basically. And since that is the case, what I'm expecting here is blown fuse, shorted transistor, and shorted diode. It's nice and light. Got it for $5. Awesome. Now, let's see if I can just hang up. Maybe I just need these. Let's see. Just keep them there. It's been a while since I had a 400 watt PSU on the bench. They're not really worth that much. Remember times when 250 watts was standard. Okay, there. Let's place the ticket number on it. So I know which one it is. And very few wires. Let's see, that's the switch 115 to 230 switch. Let's see, and has no, well, it has two filtering caps, but no filtering coil. The bridge rectifier is for diodes. Yeah. The main transformer, very small diode packs, I assume. Yeah, 1, 2, 3 diode packs. The feedback circuit, or both control circuit and feedback circuit. No, that's the control circuit. The circuit that controls the main transformer, and this is the feedback circuit that goes through this photocoupler back to the control circuit. All right. First, let's do this. This guy. Oh, let's put this screw. And one more over here. Okay. Now this guy. Everything's so flimsy. It's a technology from back in the day. Okay, I love these because they're like super simple in design. Alrighty. Do I actually need to get it out? Because I have perfect access here. So let's do some basic measurements. Let's see all our shorts. So first the fuse. The fuse is good. And that is the output of bridge rectifier, not shorted. Let's see the transistors, not shorted. I was expecting some shorts here, or at least blown fuse, and could it be misdiagnosed? So the owner, oh, that is horrible soldering. The owner, it stopped working, but maybe the PSU, because both PSU and the board stopped working, right? So perhaps it's coincidence, the board stopped working, but the PSU was okay. Okay, that was to be expected. Okay, this one's good. Let's measure this one once more. Because in one of these I made measurements once, and then when I measured the second time, some of them turned out to be okay. So I prefer to measure twice. So this one's a goner. This one's good. And this one. Oop. And this one's a goner. Let's see this one. .2 millifarad. Well, this one's 470. It's giving me high value, but there's probably another one somewhere here. Why is it giving me such a high value? Okay, what are these? 1000 at 16. Let's see if I have these. 1000, that's very little. but this is only 400 watts, so you don't need huge capacitance on the output. Let's check this guy. And actually the ground will be here. Not hugely important for measuring, but it's better to keep the polarity as designed. 1700 and it is 470. But there's another one over here, so it's measuring probably along. No, it's not along this one. As long as it's giving something. Yeah, so it's this one's 1700, so it's these two are in parallel. Alrighty. Let's check the diodes, but if they're not sure that they should be fine. Okay. Oh, it's measuring drop in both directions, but it's I would have to disconnect them because they're connected to, so this is positive, this is negative, so this is the regular direction of the diode, and in reverse I get pretty much the same thing, but you can't really measure that in circuit. Actually, a few days ago, well, maybe not a few days, but maybe a few weeks ago, this one has a very small drop. I watched the video of the guy repairing the PSU, and he was measuring the diode in circuit, and it was showing up good. And then he tested AC voltage coming to the diode was good, and going outside the diode, the DC voltage 0. And it turned out that that diode was indeed broken, but it was testing fine because of another diode in the circuit. Okay, so is this diode here shorted? Let's see the resistance on it. 46 ohms. If it's on 12 volts, that might be okay. It's not that short. Let's see if it's on 12 volts. That's the big choke, so it's probably 12 volt choke. No, this diode looks to be on a 5 volts. So that is a bit concerning, this tiny resistance. Okay, let's do this. Let's just connect it through a light bulb. Something I usually don't do before recapping. I usually recap first and then I test it, but in this case, since it's the extremely cheap device that I might be able to sell for maybe $15, if that, and I purchased it for $5. Let's see, let's hope it's got the ground. Let's see. The ground's not connected. Oh, and there's but this one and this one is fine. It should be fine. We'll see. And connection here. Nothing happened, so that's a good thing. If it was shorted, the light bulb would have lit up. Now let's give it a professional on switch. Okay, I can load this. Let's just do professional tweezers. Okay. Let's use this guy. It's a bit more reliable when it comes to measuring voltages. I got 0 here, and we've got, so at 15 for a second, and we have 0.5 volts. So this is likely because of the caps, but let's see. Oh, and that was 12 volts, and now let's see 5 volts. Do we have 5 volts? Nothing on 5 volts. 0. Complete 0. Let's see. Well, if the what do you call it? The fan's not gonna turn on when there's no 12 volts. Well, let's connect it and see. Maybe it uses standby. Now it's 12 volts, so yeah, it's not gonna start. Okay, likely. Let's get the oscilloscope, and just out of curiosity, let's check this. Channel 1. Where are you here? Let's do everything. No. Oh. Come on. Hold it there. And okay, let's see the input over here, but yeah. Okay, so there's no signal. Let's just see. So it's LC circuit. So one cap was good. Let's see if it's the 12 volt cap. It is. But on 12 volts we have very little. Oh no, this one's broken. This one is good. So that is ground on this side. Yeah, that's 12 volt rail. So 12 volt rail capacitance is good. If this was actually shorted, then we would have completely different what do you call it, the symptoms. No, actually, especially in tiny circuits like this, There's almost nothing on the transformer. And here we have nothing. Okay, let's see if we have 300 volts on the input. So we can just check on the caps. Too high? Why did it not out of range? Oh, but it did beep, so 169 volts, high voltage. So we've got this guy. So likely we can check whether we get power to the control circuit. What is the control circuit? I don't recognize it by the package. UTC 7608B. Let's see that guy. I don't have the keyboard here. We need to check on this computer. Okay, let's see. UTC 7608. 7608. Power management chip. Yeah. In stock. Data sheet. Come on, I just want to see which leg is the VCC. That's it. VD, no, that's a different thing. That's a different one. Oh my god, why is it so difficult to find this? No results found. Just the pin out. Nothing more. Exact 603. This is a yeah, all data sheet doesn't have it. That is so frustrating. This is 78D08, that's different. That's a different chip. This one and this one will be a data sheet, but no, I gotta sign in to see the data sheet. No way. No way. Okay, so we don't know. We don't know which leg is the VDD. So let's reverse engineer. It will likely be powered by because there's not going to be standby voltage here yet. It will control the standby, so it was likely powered by one of these two resistors here, or these two resistors. Let's see. Yep, these two resistors. So the VDD is this one. Let's see which one's going to be in the ground. Crap. Oh, I can just use the negative terminal of the capacitor. And we have no voltage. This is the output. This controls the resistor. So this side is the logic. And nothing. Yeah, nothing, because I'm using the wrong multimeter. Okay, once again, and the negative off. And now we have 0.2 volts. That's not enough. That should be a lot more than this. Oh, 5.9 on this one. Maybe this is VDD. That one might be ground, because it might go through resistors to ground. This is 1.1. Let's see it on the scope. Yeah, there's a beautiful square wave. So the control chip is generating signal. So let's just do a quick test. Oh. So this chip is also responsible for standby voltage, and actually I didn't check standby. PS on, okay, 3.3 SB. SB should always be present. But it should be there because, actually let's do this ground. And which one did I say? This one somewhere here, so this is likely it. No standby. But there is a damaged capacitor on the standby, I think. And actually, let's trigger the on switch. And now check PS. Nothing. Okay, so we have no standby. Oh, crap. Yeah, that's how you do the measurements on a PSU that is turned off. That is the way to measure. Yep. Okay, we have standby. Alright, so if the standby is there, the repair should be simple. That means that this chip is powered. It's just because of the caps not delivering power. So I will bet you $5 that after replacing those caps it'll start. Which is not always the case. But it should be here. This one here. Actually, let's disconnect it and remember that these caps are still charged. So try not to touch them. Oh my god, which one? This one. And this one, right? These two fellas. So this is 10 volt. Hang on, so this is 5 volt rail. So we can get 10 volt, but I don't have such a small cap. So now it'll be 3300. Negative here, positive here. It's cap number 1. Guy number 1 and number 2 is on what is this rail? 12 volts here, so that's the 12 volt that I haven't replaced, and this is 3.3. What was the original cap? 16 volts, and this one's 10. I believe this one has been replaced before, because it's very unusual to see a 16 volt on a 3.3 rail, and it connects 3.3 should connect it to ground. Yeah, there's a jumper here. There's a jumper, and it connects it to the ground. So that's weird. What did I say? 1000. Let's do 1800. 1800, and that's gonna be 6.3, because I do believe that this has been improperly replaced. I mean, not improperly, it's, you know, it's not gonna break anything if you put 16 volts instead of 10 volts. The other way around, it will, but this way it's not too bad. One and two. Okay, I didn't check 3.3, but I will now. Ground here, and let's check 12 volts now. I didn't change the cap on 12 volts though. I might, because I don't trust the measurements in circuit. We're still connected through the light bulb, so I'm not afraid of anything. And we have 12 volts. There you go. So let's connect the fan like so, and there you go. It's like new. Now let's try putting some significant load on it. But for that I need to connect it normally, not through the light bulb, because the light bulb won't allow such such power to be generated on the output. See, I didn't even have to desolder the wires. Okay, as long as you have standby voltage, the repairs are easy. If you don't have standby voltage, then that chip, where is it, that one, and everything surrounding it needs to be checked. Then obviously transistors, one of these small transformers here, one of them is responsible for standby voltage. But as long as you have that, then the rest is easy, because this circuit is a lot easier. It's easy to fool if you don't know whether because normally you get the data sheet for this little chip that generates standby voltage, which means you know which leg is the feedback that controls the PWM. If there is like a short or something on the output, and then it'll get that feedback and it won't even turn on. So you can either fool it or you can just read it, what the voltage is on the sense, what do you call it? The sense leg of the IC. And once you have that, it's easy to go from there. Okay, first things first. Let's replace the power from the light bulb power to unprotected circuit. Oh, I didn't check 5 volts and I didn't check 3.3. I just checked 12, but it was missing 12 and 5. Let's check 5 volts. So now it'll be an unprotected circuit. So now we need to be careful. And we have beautiful 5.11. Okay. Now let's connect a dummy load and I'll check on dummy load voltage drop, but that's not what you should do. So I'm expecting on 12 volts to drop, although it's kind of closer here, but it shouldn't go below 11.3, at least on this load. But I'm measuring on the same cable that the load is connected to. If you measure on the separate cable, which I'll do in a second, the voltage drop should be minimum or almost no drop. And we have 1132. Yeah, that's perfect. And let's see on the different wire. So this is the separate wire. Drop over here should be significantly less. 1207 from 1209. Yeah, so basically no voltage drop. And this heated up very well. Oh, and the cables here are hot to the touch. Well, not hot to the touch, warm. These are hot to the touch. And if you let them run for a minute, they'll just burn. These are rated for 10 watts, and I'm using it as like close to 200 watt load. But the PSU is like new. All the caps replaced, and back to eBay you go. I don't know if I'll be able to sell it. I don't know if anyone buys these things anymore, but this was the cost of repair, so around 60 cents. I bought it for $5, so I'll just probably sell it for like 15. And that'll be it. Alright, I don't want to bore you guys with assembling it back on camera, so I'm just gonna call it repaired. It will be available on eBay in a few days. This is 400. Where's the here? So this is 400 watt power supply. On 12 volts, it's capable of generating, of outputting 216 watts, and 182 watts on, well, 3.3 and 5, 22 amps per each. So it can still be used as pretty reliable LED lighting. What do you call it? Brake. Let's call it a brake. At how many amps did I say? At 200, so 18 amps. So quite a few LEDs you can put on it. All right, thank you guys very much for watching. I hope you enjoyed this very short. It is very short video on fixing old PSUs, something that probably isn't very useful anymore, but Remember that every PSU works pretty much on the same principle, although the, I don't know, more modern designs are a bit more modular, and obviously they need to be built differently because of how much power they need to deliver. This is 1 kilowatt, so 5 times more than this little one, and you can tell by the weight of it. This one's very light, this one's pretty heavy. Alrighty, thank you very much for watching, and I shall see you guys in the next one.